In this video, we're going to pick up where we left off in class in lesson 5.3 with the third problem about microbes in an experiment. So specifically in this problem, we get told a couple of things. We're told that we start with 500 bacteria and that every hour, each bacterium splits into 2 bacteria. So 1 becomes 2. The first question we're asked is to write an expression that would let us find the number of bacteria after each hour using this table. So we know right off the bat that each hour, essentially our population of bacteria doubles because each bacteria becomes 2 bacteria. So if we start with 500, in order to find the next number of bacteria, I'm going to say, okay, we're going to do 500 times 2. Right? I'm going to double that. So that's going to give me 1,000 bacteria. Now, in the next part of this, so after 2 hours then, well, I'm going to take whatever number that was, and I'm going to double it again. So I'm going to take that 500 times 2, and I'm going to multiply it by 2 again. So there's another way we can write this, though. We can write this as 500 times 2 with an exponent of 2, because that little exponent there means that I'm multiplying by 2 twice. Okay, well, when 3 hours have passed, I'm going to multiply by 2 again. So 500 that we started with, times 2 for 1 hour, times 2 for another hour, times 2 for that third hour. And again, I can shortcut this expression by writing it as 500 times 2 to the third. So you might kind of see where this pattern is going. If it's been 6 hours, well, then I'm going to have 500 to begin with, and I'm going to double it. I'm going to multiply it by 2 6 times. So it's times 2 to the 6th power. Now, in this case, in the last row, they don't tell us how long it has been. They just leave it as t. So in this case, it's going to be 500 times 2 with an exponent of t. And I don't know what t is, but we can fill that in whenever we get around to it. So the second part of this, part B, now wants us to write an equation that relates n, the number of bacteria, to t, the number of hours. We pretty much already figured this out. We figured out that in order to find the number of bacteria, I use this expression right here. So my equation is going to be that n equals 500 that we started with times 2 with an exponent of whatever t is. So if it's been 10 hours, then t is going to be 10. If it's been only 3 hours, then t is going to be 3. And then we can use this equation to find how many bacteria there are, to find n, when t is 0. So let's try that. N equals 500 times 2 with an exponent of 0. Well, we saw earlier in the lesson that 2 to the 0, or anything to the 0, is just 1. So this means that n is 500. Well, what does that mean in this situation? That is the starting amount. That is how many microbes there were, or how many bacteria there were at the beginning. And we're going to notice that is actually kind of a pattern here, where this 500, this number at the beginning, is going to be our starting amount. That's going to be a helpful pattern when we get down to the second problem, where now we're looking at a different experiment, and we're told in this case that parasites also reproduce hourly, and they tell us that the number of parasites, P, after a certain amount of time has passed t, can be found with this equation. P equals 100 times 3 with an exponent of t. And they want to know, what does that 100 mean, and what does that 3 mean? So in this case specifically, the 100, like we just saw above, is the number of parasites at the beginning. Or in other words, when t is 0. And the 3 is the growth factor. Now this might be a new-ish vocab word, but we just said earlier in class that factor is the thing we are multiplying by, right? The number that we multiply by each time. And that's exactly what a growth factor is. It's, hey, I know this population is growing, but by what factor? Well, it's growing with a growth factor of 3, means I multiplied by 3 each time.